Text-to-visual generation has made incredible strides, but there's a subtle bottleneck. We've gotten very good at scaling the visual generation, larger diffusion models, more VRM, etc., to produce higher resolution, more detailed images and videos. However, the initial prompt often remains fixed. This means that even with a stunningly powerful visual generator, the alignment between the user's intent, expressed in the prompt, and the final output can plateau. The model isn't truly understanding the prompt better, it's just generating a higher resolution, more detailed version of a potentially flawed interpretation. The aha moment is realizing that we should scale the prompt in tandem with the visual generation process. Instead of treating the initial prompt as gospel, we should iteratively refine it during inference based on the generated visuals. Think of it as a dialogue between the prompt and the visual output, where the visual generation informs the prompt on how to better express the desired scene. This allows us to leverage the scaling laws of the visual generator more effectively. The paper proposes prompt redesign for inference time scaling, or PRIS. The key components are, first, the text-to-visual model generates an initial visual based on the prompt. Then, a verifier assesses the alignment between the prompt and the generated visual. Critically, this verifier is not a generic image captioning model, but a fine-grained element-level factual correction (EFC) module. EFC dissects the prompt into individual attributes, color of the cube, shape of the object, etc., and verifies if each attribute is faithfully represented in the visual. Based on the EFC's feedback, the prompt is then automatically revised to correct any discrepancies. This redesigned prompt is then fed back into the visual generator for another iteration. This process repeats until satisfactory alignment is achieved. The experiments demonstrate that PRIS significantly improves both prompt adherence and visual quality compared to simply scaling the visual generation model. By jointly scaling the prompt and the visuals, PRIS unlocks the full potential of scaling laws. This is a crucial step towards building truly intelligent text-to-visual systems that understand and execute user intent with high fidelity. Furthermore, the paper introduces a new benchmark for evaluating verifiers specifically in the context of inference time scaling. This will accelerate research in this area and allow us to develop even more sophisticated prompt redesign techniques.